Solve x prime minus 2y equals 4t, y prime plus 2y minus 4x equals negative 4t minus 2, where x of 0 equals 4 and y of 0 equals negative 5. Before we start solving this system, notice that t is the independent variable and both x and y depend on t. This can be a little confusing if you've gotten too comfortable always thinking of y as a function of x. Second, since this is a non-homogeneous system, which we can see by noticing the terms that don't involve x or y, we haven't actually learned how to solve this system using the matrix method. But we can solve it relatively simply using Laplace transforms. First, apply the Laplace transform to both equations. Using the linearity and derivative properties of the Laplace transform, we can rewrite these equations. If we replace L of x with capital X, L of y with capital Y, plug in the initial conditions, and use that L of t to the first equals 1 factorial over s to the 1 plus 1, and L of a constant is c over s, we get sx minus 4 minus 2y equals 4 over s squared. So sx minus 2y equals 4 over s squared plus 4. And sy plus 5 plus 2y minus 4x equals negative 4 over s squared minus 2 over s. So negative 4x plus s plus 2y is negative 4 over s squared minus 2 over s minus 5. Again, we've reached an algebraic system that we can solve by whatever method we prefer. This time I'll solve it using elimination by multiplying the first equation by s plus 2 and multiplying the second equation by 2. Now, adding the two equations together gets rid of the y terms and leaves s times s plus 2x minus 8x is 4 over s squared plus 4 times s plus 2 minus 8 over s squared minus 4 over s minus 10. Multiplying everything out, s squared plus 2s minus 8x equals 4 over s plus 8 over s squared plus 4s plus 8 minus 8 over s squared minus 4 over s minus 10, which simplifies a lot when we combine like terms. So x equals 4 over s minus 2 over s squared plus 2s minus 8, which factors as s plus 4 times s minus 2. We could find y right now, but it will be easier to just use that x prime minus 2y equals 4t, so y equals 1/2 x prime minus 4t once we know what x is. So instead, we're just going to find lowercase x, which is the inverse Laplace transform of capital S. To find the inverse Laplace transform of capital X, we need to use partial fraction decomposition on x so that we can match it up with entries in the table of Laplace transforms. We can decompose x as a over s plus 4 plus b over s minus 2. So 4s minus 2 is going to equal a times s minus 2 plus b times s plus 4. When s equals 2, we get 4 times 2 minus 2 equals 0a plus 6b. So b equals 1. And when s equals negative 4, we get 4 times negative 4 minus 2 equals negative 6a plus 0b. So a equals 3. That tells us that x is 3 over s plus 4 plus 1 over s minus 2. And since 1 over s minus a is the Laplace transform of e to the at, x is equal to the Laplace transform of 3e to the negative 4t plus e to the 2t. So that means that lowercase x is 3e to the negative 4t plus e to the 2t. Finally, we can find y using that y is 1/2 of x prime minus 4t. X prime is negative 12 e to the negative 4t plus 2 e to the 2t. And then we have to subtract 4t from that. Then divide everything by 2 to get negative 6 e to the negative 4t plus e to the 2t minus 2t. The solution to our initial value problem is that x is 3e to the negative 4t plus e to the 2t, and y is negative 6 e to the negative 4t plus e to the 2t minus 2t.